Okay, again, this crazy graph, we're just using this for representation. You don't have to write it down. If I wanted to find the derivative of the inverse, so this is a lot of notation, but if you just look at it, it's not as intimidating as it might look. So f inverse prime at the point A. So it's asking for the derivative of the inverse function at A. All right, so if I go down here, so I'm looking on this bottom curve here. If I want to find the derivative, that simply means the slope of the tangent line on that curve at A. And so rise over run, it would be P over Q. All right, so again, this notation, it looks like a mess, but it's really all it's saying is I'm trying to find the derivative at A, so the slope of the tangent line at A of my inverse function. Okay, now if I want to find the derivative of f inverse of A, so now my input is over here. So I'm not looking at A, I'm looking at f inverse of A. So essentially my xy coordinates have switched. So the first one was A comma f inverse of A. And so the inverse function is going to be f inverse of A comma A. So if I wanted the derivative of f inverse of A, I can look at it, rise over run, I'm rising Q and running P. So the slope of that line is Q over P. So therefore, if I saw the first one as P over Q and the second one's Q over P, I can rewrite this top one and say, well, that's the same thing as 1 over Q over P, or 1 over F prime F inverse of A. It's a lot of notation, but really all we're doing is, I mean, we're doing it in terms of inverses, but it's 1 over my other slope. Okay, so again, that graph, there's a lot going on with it. Well, what this is finally saying is the derivative of an inverse function at A is 1 over f prime f inverse at A. All right. So we can write this in terms of x as well. So if my function was in terms of x, this is the exact same thing that I'd written, but now it's just in terms of x. Where often now we'll write, instead of saying f inverse, if I have some function f of x, rather than writing f inverse of x, I'm just going to say, well, the inverse function we'll call g of x. So I have f of x and I have g of x, which is the inverse function. Then I could write it like this. So g prime of x, that's finding the derivative of the inverse function, is simply 1 over f prime of g of x. So you can see it's getting into not really chain rule, but it is kind of chain rule. But we just leave it just like this. There's no g prime in the denominator or anything. So the derivative of an inverse function, when our inverse function is g of x, is simply 1 over f prime of g of x. So this is a formula that you'll be expected to know now and use on AP Classroom. I think there's 3 questions that deal with this. And then also this is fair game for the test. Okay, so when we're working with inverses, we say g of x is the inverse function, then g prime of x is 1 over f prime of x, f prime g of x. Okay, so let's actually do one, put this all together. Might not be able to read it as well from the back, but it says the table above gives selected values for a differentiable and decreasing function f and its derivative if g of x is f prime of x. So they're already putting it into that form that we know we want to work with. So we're going to call now our new g of x function the inverse of f. Which of the following is the correct expression for g prime at 2? Okay, well, we did that g prime of x is 1 over f prime g of x. So we want to find it at 2. So this is 1 over, oops, want to find it at 2. So it's 1 over f prime g of 2. What is g of 2? It's 4. Do we understand why it's 4? Because if we were looking up here, if I had some coordinate x, well, let's say some coordinate, let's work right here. So this is 4 comma 2. That's in terms of f of x. Or I could say f of 4 equals 2. Remember now, so then f inverse is going to say f inverse of 2 would equal 4. But f inverse is g, so g of 2 is 4. So for this one, then we would say 1 over f prime of 4. What is f prime of 4? -5. Okay, so -1/5. So if we look over here at our options, it would be this option C. G prime of 2 is 1 over f prime of 4, which is -1/5. All right, but it all builds from this inverse derivatives formula that we need to know from here going forward. So put a star next to that, box it in, whatever you need to do. And then this one, when it was a table, we need to recognize g of x is the inverse function. That we know f of 4 is 2, so therefore the inverse of 2 would be 4. And that's the same as g. So then we have that piece to fill in. Okay? All right, so I want you to work on Unit 3 progress check. All right? Work through these problems. There's 18 problems. Okay? So I have it set due for tomorrow. So you're going to have to put some work in the rest of this hour, put some work into it this evening, and then we can talk about a few of them. I will do every single one and post my solutions, work solutions as well. Probably not before the start of class tomorrow, because I want you to ask me questions. I don't want to just post the solutions yet. Have those ready to go, and then tomorrow, our last day together for a few weeks, we are going to cover L'Hopital's rule, which is not hard. Okay, but it's just another piece, and it's working with limits, but it's using derivatives within limits. And so that's why we waited to this point to actually start working on that. So we'll do that tomorrow, and then that will be all the content that we're going to cover for this term.